Good morning. Hello, David. Hello, good morning. Good morning.
Morning, Michelle.
Good morning, David. How are you?
Very good. Alive and well.
Morning, Michelle.
Awesome.
You?
Good morning, Michael. I'm doing good. I'm actually in California, so
Better than being
super
on the west
super
coast of
excited.
Florida.
I flew to Florida and Bahamas.
Yeah, I think my mother's house just got destroyed yesterday. Have to find out.
Yeah, definitely prayers to everyone who lives around the area.
She did evacuate, but I haven't had a chance to get back and find out. But I think there's a lot of people digging out, man. 2 storms back to back. But there's no such thing as climate change or anything. That doesn't exist, right? Just ask Governor DeSantis down there.
I'm not sure though, because there was one year where there was snowing in LA in February. So I remember driving from Vegas to, like, I have to drive to the Bay Area, like, due to
Mm-hmm.
snow. So I think I drove from LA to Highway 1, and it was pretty
Yeah.
awful. Luckily I didn't die, but I would have. I could have, I
And
guess.
the roads may keep getting
Um,
worse.
yeah, yeah. So hopefully, I don't know. I heard that there are things happening in Europe as well that is a little bit different,
Oh God, yeah. Okay,
weather-wise.
so it is so hot in Europe, and it has been now for probably a decade, that you know how there are all these wonderful water fountains that are, for looks and everything, which probably originally water fountains were really to get clean water, but they're all looks. You're not allowed in the water, right? Um, in Europe, all summer long, everybody's in the water fountains. That's Yeah, that's
Wow.
I was in Norway, and I'm looking around, going, I mean, it was, you know, brutally hot, and everybody's in the water fountains. So kind of that whole cultural thing change really quickly.
Yeah. To the extent that it's dangerous and kills people, like we should, um, be a little bit more aware of climate changes.
Yeah.
Um,
Anyways, it was just a little history. But
yeah.
hopefully my mother's okay and my sister
So
and
I'm
anyone else
pretty
who
excited
happens
about
to
the.
be down there right now.
I was just talking to a friend who lives in Tampa, and it was definitely an emergency situation. So
Oh,
yeah, hopefully, yeah, exactly.
Tampa is right down Sue's Venice. Uh, myself, so absolutely same area, and got hit. Yeah, I've been. There's great YouTube videos these days. It's amazing all the cameras to. You can see absolutely everything.
Yeah, I'm pretty excited about this space.
Mm-hmm.
With you, David, as CTO PraSaga, and I've known you for many years. So I basically told everyone that you were like a genius, and a- and influenced a lot of the internet. So I think we're gonna begin. We'll wait a little more, like
Sure.
a few more minutes to go into more of the deeper updates. But let's begin by um, with a little introduction. So I'm Michelle. I'm one of the advisor of PraSaga from a long time ago, and I'm helping with marketing and just really sharing about PraSaga and what PraSaga has done. So I'm pretty excited to chat with you here, knowing you for so long and really supportive of your work. Do you want to provide us with a little bit of intro about you, how you have influenced and help in the internet ecosystem that of what we know today? And then and give us a little bit history of how you became CTO
Well, that's
PraSaga.
a lot. Anyways, yes. Thank you, and thank you for supporting us for so long. And your line about geniuses. I've worked in my life with real geniuses, people who are like the guy who invented the electrophoresis, the Western blot electrophoresis gel. That's the basis for DNA sequencing, that type of stuff. Nobel Prize winner, and I was actually taught by the Nobel Prize winner for the CAT scan and that type of stuff. So I can tell you with absolute guarantee that I'm not a genius after having met them. Just want to be clear on that one. They're way out there, and I do know how to tie my shoes, which is also a telltale that I can't be a genius. Um, what did you ask me? Real quickly, my background: I'm an electrical engineer, computer engineer, software engineer. Started writing software when I was about 14 years old. Built my first, ham radio out of Heathkit when I was, I don't know, 10, 11, 12, something like that, and was playing around with Radio Shack experiment boards like when I was 6 or 7. So, it's been my whole life. Um, Turns out I'm not a particularly great electrical engineer anymore, but I have written a lot of software. I think you asked a little bit about the internet. Um, I've had some personal impact on it, when it was a lot smaller and a few people could do a lot more. In the late 1980s, I was the network management special interest group secretary over at NIST, and that's it's just Standards and Technology, Science and Technology, which is the precursor pretty much to uh, the way we manage the telecom systems. It was this is when Simple Network Management Protocol (SNMP) was just coming out, and their approach was what's called ASN1, Abstract Syntax Notation, and managing objects and systems, viewing the network as objects, managing them that way. From there. I, you'll find my contributions in the internet protocols in various places. The one of my significant ones is the block acknowledgement protocol for Wi-Fi 802.11. You won't find my name on it. I was at the 802.11 meeting and went over to the people working on that particular piece of the spec and said, please put this in because I was designing something with it, told them how to do it. And then you'll find the port address translation of the NAT box. When I was over at a company, Routerware, we were pretty much the first ones um, putting that out. In fact, I believe we were the first ones putting that. That became Wind River networking stack, and you use it. You all use today various versions of that, of course, and now it's in the Linux network IP tables and that type of thing. I also did a couple of things that never saw the light of day, which was a web farm load balancer, but unfortunately it didn't quite. My approach was with a company you might remember called Gateway. They bought a company called Advanced Logic Research. I was doing it with Advanced Logic Research. Gateway bought them for about $250 million, and then 6 months later decided they made a mistake and shut the whole thing down and threw me out with it. So you can't always have those. You also probably know what HDSL is. In the first when we used to run the internet over copper, between when you had dial-up and we had fiber. I'm one of the pioneers in the DSL market and did probably the first Ethernet over HDSL with the Baby Bell companies. Can't remember the names of them anymore. Anyways, that's the background. Wrote a lot of software, did all that. I think you want to know. Do you want me to talk about real quickly about how we founded this? Okay.
Yeah, like I'm interested about how, like, who came up with the idea, what was your aha moment,
So
and like what,
I thought
yeah.
about this. First of all, to be clear, Mike Holdman, who's also on the call with us, and myself are the co-founders of PraSaga. Um, we ran into each other, which is the evolution to where we got here. We ran into each other at various trade shows when I was working with a embedded real-time Java programming language company of all things. And I was focused on the Internet of Things with the in one of the early adopters and early members of the Internet Engineering. Sorry, the Internet, the Internet of Things, the IIC, Internet Internet. The hell's the IIC stand for? IoT, the IoT consortium, originally started by the OMG Object Management Group, and I was a member of it for well, technically, I probably still am a member of it, personally, and for my company then. And Mike Holdman ran into me. He was doing a messaging bus, an internet messaging bus, so a distributed system that's perfect for hooking together IoT devices. And we put some solutions together, and that brought us to a blockchain solution. And what happened is we went to design a solution with the existing blockchains. At the time, throw out a couple names. Of course, Bitcoin was around, Ethereum was around, Stellar was around, a whole bunch of them were around, and IOTA was around. So give you time frame 2018 or so. And when we were looking at it, we ran into two problems. One of them is the performance of blockchains for what we wanted to do was not stable enough. Um, you need to be guaranteed that when you put a transaction through, that it will go through in a relative amount of time and at a relatively stable cost. And we were able to see that that wasn't going to happen. We're also able to see that as we wanted it to grow in capability, it was going to slow down. And that brought us to, okay, we need to come up with a scalable design that supports relatively stable cost. and a relatively stable transaction throughput. And that's really where this comes from. Everything else kind of evolves from it, but that was the original aha, we can't build what we wanted to build because technology wasn't ready for it yet. And that's why we're doing this, actually. That's the fundamental motivation.
Let's talk about differences. And let's just go over some of the other chains on the market right now. Of course, the first one is Sui. Sui is really, really hot right now. How is PraSaga different from Sui?
So, two things. I have to be clear that I don't study everybody else's chain all the time. Okay. There was a time when I was reading every white paper on every consensus protocol, plus going through the history back to, the raft protocol and those types of things. So if I if I misrepresent another chain, my apologies. Uh, Essentially, though, at the very high level, um, our approach. So I view us as the third approach to the data model for how to manage blockchain. Okay, the first model is Bitcoin model with UTXO, right? Very well understood. It's a non-Turing complete script approach. It works really, really well for just moving ownership of, in this case, arbitrary coins around, but really could have been anything. Um, then along comes the smart contract, which is kind of like doing multiple versions of Bitcoin on the same chain, where you're attaching code to it, and instead of I'm sorry, and your accounts are represented as entries in the smart contract, and then the job of the blockchain is to maintain the states of the smart contracts. Now, I believe the third one is that I believe that Sui has also come up with the idea that there is a concept of essentially global objects, which you could think of as global smart contracts, which other smart contracts can refer to. Right? I believe that they have that capability. Um, we kind of turned that all on its head. I'm sorry. One other piece, remember, is that the big advantage of the smart contract over the Bitcoin is that those are Turing complete programs where you use the cost of execution, gas normally called, to avoid the regular terminating, halting, well known Turing halting problem that Turing himself defined and wrote up. And that's the famous, his famous uh, uh, solution. The What we did was turn the model on its head. Instead of looking at, and there's a reason for this. Everything we did, first of all, everything we did is to promote scalability, dynamic scalability, stability, capacity, transaction capacity, all those things. And what we did is we turned the model on its head and said, instead of having a smart contract that has data inside it, which represents all of the accounts that are currently part of that smart contract, meaning usually how much coin they own, but actually it's an array of anything you want it to be. Each account owns its own data. And that allows us to do something very interesting when it comes to parallel execution on multiple shards. But that's the core difference in the data model. And that enables a scheduling algorithm. It allows us to do scaling and sharding without doing cross-shard communication, without doing cross-shard transactions, rather. We do cross-shard communication. We don't do any cross-shard transactions. And we do that without full-time partitioning like you would in an L1, L2 solution also. So by reimagining the data model of what we're doing, we can enable that. And that's kind of the core, the ability to schedule. That's the core piece of our technology when it comes to scaling and performance. There's other pieces, but that's that piece.
Awesome. And how about Metaverse X?
Which one's Metaverse X? They do. Mike, give me a memory so I can answer which one's which. Can you mute for you there, Mike? Can you mute for a second?
It rebranded not that long ago, Dave. It used to be called Elrond, and then I think it was called EGLD, or maybe that was just the ticker, but
Yeah, I just
it's
got up
rebranded
there.
twice.
Metaverse X is doing the sovereign shards.
Oh yeah, okay, yeah,
And,
good. Let's talk sovereign shards. Okay, that's close enough.
Yeah,
Right.
yeah.
So
Yeah, with the
right.
partitions.
So we're
Yeah,
doing
or
we are
sharding.
doing a sharding where the data is, think of it as lazy synchronized, temporarily sharded. Eventually, all nodes know all shards, all shard chains, right? And the data at if you wait long enough, all nodes will have all their state up to date. Um, we don't do a full time partitioning. We don't do that because it enables all the scale we want to be able to do. We do something else, though, and I want to talk specifically about the sovereign chain versus what we're doing. Um, because we can control with a scheduler, and the scheduling is still a decentralized system, where transactions execute and account state goes, it is possible to create, instead of a sovereign chain, but we kind of came up with the word enclave. What that allows you to do is have a shard or set of shards that are managed by designated nodes that run designated accounts while still being able to send out um, summary or opaque information to the rest of the uh, chain and take advantage of the hash power of the rest of the public chain. This is a It's not an L1 L2. It's not a sovereign chain. It's a different concept, and it's targeting specifically situations where, say, multiple businesses want to take advantage of the security of a full public chain, but also don't want to expose their own data. Um, and so they still want to exchange it between each other. And so we have ways to pull that together because, again, of focusing on the account as the uh, container of data and the objects within the account. We have to talk about that a little bit versus the smart contract, which is this serialized entity that contains all the data of all the accounts that are related to it. So, go ahead.
So David, thank you. Near and Solana are next, and they're a pretty big chain. So among all the L1s, how is PraSaga different from Near as well as Solana?
Okay, Solana does the shredding, and Near is the. No, that's Caspa. Wait, I've read Near.
Yeah,
Near
near is
does the
another
microtransactions, cross shard
partition
micro,
sharding.
Mike.
Yeah.
Yeah. Okay. Yeah. Sure. So let's you're asking questions that take a lot of architecture design to explain the differences, which I'm sure you're aware. Solana does breaks up their transactions into what they call shreds and sends them out in parallel to multiple nodes, and then those nodes exchange with each other. And in the end, everybody executes all the transactions. Right. What it does is it takes the network traffic and creates a less of a bursty network traffic because if you have let's say I have a megabyte block and I'm going to send it out to all the nodes, I got to send it out to all the nodes. If that creates a burst both on the sender and across the network to each one. If I say break that up into 100 megabyte blocks and send some of those blocks to one node, some of those blocks to, I mean, one of those blocks to some of the nodes, a different of the blocks to different nodes, and then have them exchange. At any given time, you're only sending 100 megabyte blocks instead of gigabyte blocks. It's a kind of like a pipeline type architecture. It works very well for optimizing the network. It doesn't actually change the throughput of the transactions. Okay, because you still have to execute all the transactions. So for us, a key difference in sharding is that then when a node is on a shard validating a block, it has to execute the transactions. If a node's not on the shard, it receives the previously consented blocks and is then able to, instead of executing the transactions, just update its state. And if you can't do that, if you have to execute every transaction on every node, then in the end, your throughput is limited to essentially either the average of the speed of all the nodes executing that are running the blockchain, or the average of the supermajority of all the nodes running the blockchain, depending on the consensus algorithm you're using, right? So our key point is we're not doing that. So what we're doing is sharded execution. Okay, we're with a late synchronization of data. We're doing sharded execution, and as a result, the more shards you have, and if you forget about each shard being a consensus, think of each shard as its own CPU for the moment. If I can run multiple CPUs in parallel, the more of them I can run, the more capacity I can have for the chain. So that's basically what Solana is doing. What Multiverse is doing is a sharded chain. No, absolutely, and they are doing sharded execution. However, their approach to handling a transaction that needs data that from more than one of their their smart contract model, is what happens if I have a smart contract with its state on one shard, and I have another smart contract with its state on another shard, and worse, let's say I have a third one on another shard, and I wrote a smart contract that's calling between them. Right now, we do very primitive ones. We know them as DeFi. But what happens if you really want to get complex? Their approach is to do micro transactions between the nodes using a thanks, Mike. By the way, is using a microtransaction approach where they essentially stop the transaction, create a separate transaction, put it on a overlay beacon or mainnet chain, have that reach essentially consensus, have the targeted shard then read that, do a local execution, right? Then send the result back in yet another transaction, you might say. And there's a paper that shows a 5-part exchange to be able to pull that off. There's nothing wrong with this. That works. Let me be clear. Sharded systems work. The question is, how much congestion do you end up with as the types of things we want to do with the blockchain grow? To put it simply, if I'm only ever managing the ownership of a single token in a single smart contract, then I can put that smart contract on at least a shard and it'll run as fast as that one shard. It can't run faster than that. We actually can, but normally in a smart contract world, you're limited to the serialization of a single shard. But that then becomes much slower as you have to essentially message between the shards, and now you're tied to the throughput of one overlay chain, mainnet, beacon chain, whatever you want to call it. And so we spend a whole bunch of time trying to avoid all of those issues, which are what a NIR does, what a I can't remember all the names of the shards. I mean, of all the chains, but most of the sharded chains are following that type of approach. There is, to be clear, I believe there's one other sharding chain out there that's done something slightly different, where it looks like they're viewing the state as reading it from an IPFS type solution, and then the nodes, I gather, are pulling from that continually to assign themselves to individual shards. I didn't look at it too deeply, but it looks it's an interesting idea. Your overhead though is now, your throughput is now limited to being able to pull the data that you need out of the IPFS system, which is yet another networking overhead. You know, engineering, you push, so you know the line with the balloon, you know, you push in one area, it bulges out the other. Anyways, hope that was somewhat clear.
Awesome. For everyone else who doesn't understand what sharding means, it's just basically breaking things down. For example, if you have one big basket of apples, sometimes they're too heavy to carry. So you might want to break it down and put it in different bags so that you can carry them and transact with them. That's what sharding
Thanks. I
means.
didn't even
Um,
started too far down the line, did I? Sorry about that.
No, it's okay. I think that that's easy. Breaking down and just carrying it in different baskets and different bags are easier to transact and to transport. I used to work at Cisco Systems, so we always use the truck as an example. Uh,
Hmm.
to carry data. And I know that apples are, baskets and apples are really, really simplified, but it's easier to
So,
understand.
Michelle, one of the analogies that we do, and Dave, if you want to go through it because you came up with it, is the grocery store and the
That's
lanes in the
starting. Yeah,
grocery
yeah, yeah,
store and how smart contracts are. Right.
yeah. Do we have a second? I'll do that real quickly if you'd like. Visualize a Bitcoin or a single chain as a single checkout counter, and you're sitting behind everybody with your basket, regardless of what's in your basket, right? In a sharded chain, a basic sharded chain is um, you would have a checkout counter for each, like, say, type of thing you can buy. Like, you're the you're only able to buy groceries at this checkout counter, and so you're still lined up between everybody who wants to buy groceries. That would be like a smart contract with a token, and you're doing smart contract execution, um, and the other people are doing totally unrelated transactions, but they're using the same token, right? So in a sharded um, parallel in a grocery store checkout line, each token would be a separate checkout counter, which is still good. That's still better than having them all lined up between one checkout counter. What we want is something slightly different. If I have account A doing a transaction with account B and account C doing a transaction with account D, and I don't care about what tokens they're using. I want those to happen in parallel because they're not touching each other. So that means that I go out to this grocery counter, the checkout counter with my basket, and I can walk through any one of those trying to find the shortest line, which is what you really want to be able to do in a grocery store. So we're trying to be the grocery store checkout counter of the blockchain community.
Awesome. And if anyone could animate that, ping me and let me know.
Sure.
It'll be kind of cool to have that analogy animated, and also, or
Yeah, we can
created
show long lines.
digitally.
Yeah, what you would see, by the way, is that and of course, in a single chain, you'd see just a long line of shopping carts. In a tokenized smart contract world, you'd see some of these checkout counters with really long lines and others empty because nobody happens to be using that token at that point in time. And with us, what you should see is a relatively average, constant stream through every one of the checkout counters, like going through a toll booth. Also, same idea.
Awesome. So another thing is scalability, and I do not want to go to the grocery store, buy some tomatoes and pay $50 in gas fees when the tomato is like
Right.
$5. So how does Prasaga blockchain address scalability, and what specific challenges are you aiming to solve with it?
Well, first of all, what we're trying to do on the financial side is use a currency monetary policy, um, which isn't you don't see that in the blockchain world today. Real quickly, history: Bitcoin, of course, is the halving model, fixed number, 18 months, right? The second type of model is I'm going to just arbitrarily every block mint a certain amount of coin. And what's interesting is if you look at those two numbers and the limit, they're essentially the same. In other words, if I keep adding, as I use a bucket of water, if I had a drop to a bucket of water, an empty bucket, and I had two drops, that's twice as many. But when the bucket's reasonably full, adding another drop of the same amount has virtually no effect on it. Right? It does keep growing, but the percentage growth becomes in the limit. If for those of us who remember calculus, in the limit that would be essentially zero, but you never quite reach zero, of course. Um, the third way is to just start with one fixed amount of coin. So I'm just going to do a TGE and hey, that's it, and whatever happens, happens. None of those make a stable currency, as we've all found out. What we know about stable currencies are that the amount of currency has to respond to demand, supply, pricing. This is very well understood stuff. Um, however, for the blockchain community, that's never actually been done. And what we can do that when it comes to a blockchain, the only thing you really can control is the rate of increase and decrease of coin supply, meaning you can the rate you generate new coin at, which you can call minting or mining or any word you want for it, and the rate that it gets taken out, which is some form of burning or locking up or something else, anything similar to it. What we did is I'm not my financial modeling knowledge starts from ground zero, but we happen to have on board as our advisor a recently Nobel Prize nominated economics expert, Dr. Lawrence White. He's written 5, 6 books, and he's the chair over at George Mason University, I think. I forget where he's actually chair at. And he also had one of the books that I would recommend reading, which also has a chapter on Bitcoin, is called Better Money. And he walks through the history of gold and goes on to the general history of money and then into where Bitcoin is and points out the fundamental flaw in Bitcoin is the monetary policy, which we've worked with him to actually implement on our chain. And what that means is that it's responsive to various signals to not just increase the money supply, but be able to increase, decrease, and also temporarily pull money out so you don't necessarily have to burn it. And do that under a mathematical model, not arbitrary, like, hey, a group just got together and said, hey, let's go burn some coin. So you end up with both a stable and intentionally stabilized system and something that's not subject to the whims of an arbitrary group of people. That's I would strongly recommend to start for a background. Go read that book first, because a lot of what we're doing will make much more sense.
Awesome. David, I want you to talk a little bit about the architecture of PraSaga in just a high level. And also regarding the infrastructure, how do you design it so that it could scale and is secure? Because I think if you're in the blockchain space for a long time, you'll notice that a lot of the chains are really hype
Don't worry.
When it comes to it, and then however, it doesn't scale and it's hard to perform. Right, some of the chains are congested. I myself personally have faced a lot of challenges interacting with a lot of the chains right now. So can you just really talk a little bit about the architecture in a more simpler way, and how that's different.
Yeah, the problem is I am talking it in a simpler way. Okay, so
No,
let
no, no.
me
Just go
start
ahead,
at
and I'll
the
paraphrase.
basic point of view of the consensus. When you say architecture, I don't think you want to know about the program process architecture. I can tell you what it looks like, but I don't know if that helps you. Um, First off, the general blockchain architecture is that there's individual shards which are running a consensus protocol, which is a hybrid solution based on both signatures and proof of work. And then it's using a braiding between the shards to recruit the hash power of the nodes of the other shards. And then there's a overlay chain that is included in the individual shard blocks as well, which is used strictly for managing what we call account ownership and account migration between shards, so that there's never a transaction from one shard to another. All transactions are by definition running to completion on a single shard, non-blocking. That means that you don't go partway through transactions. Oops, I need something from another chain. I'm going to go send a transaction over to it. What did you ask me for architecture? One quick dig down about the proof of work. Our personal viewpoint is that depending strictly on signatures, which is proof of stake in the end, is signing. You can use an aggregate signature approach. We will be using a aggregate signature approach for each one. For that part of it, is not sufficient in the long run for security. And the reason why I say that is the speed of the chain is artificially slower than if I had all the keys and I wanted to make a fake chain on a single high power computer. See, in a Bitcoin world, if I have a single computer, there's no way I'm ever going to keep up with the hash power. Literally, that's why you need 50% or more to totally take over. There's other games you can play around 25%. In a signature-based world, if I can get into all the keys, or at least the super majority of the keys at any point in the history of the chain, I can fork it and create a fake chain, and there's virtually no way to tell the difference between them. And that includes also maintaining all the coins, all those types of things, because I will have access to all of the keys for it. Is it going to happen? No, but it's theoretically possible. And I didn't really want to have a chain where we're trying to say, come use this for global security for currency, and know that was sitting there. So what we did is we threw a proof of work on top of it. So it goes through and does the short-term validation of the blocks on each shard individually, and then each shard essentially has a mining pool around it that does a proof of work on it. There's a couple more details to it to make that work, but now you've got one level of hash power, but I still want the rest of the hash power of the rest of the nodes on the system. So basically you gossip the blocks to everybody else because they need the state anyway, and then any given shard can simply incorporate the hash of a block that they've received from another shard in a current block, and you essentially get braided hashing. And you can do that, of course, in parallel across multiple and make them intermix in any way that they feel like. You don't really need to be very particular about it. You just want to make sure that you get lots of overlay, because that means if I wanted to now hack that chain, I have to, even if I have all of the keys in the world, I still have to overpower all that hash power. And so I'm essentially using kind of the Tangle concept coupled with the BFT proof of stake concept, coupled with the general proof of work as a level of difficulty. So I kind of threw those all together. Works pretty well. There's nothing. It's not nothing particularly difficult about it. It does mean that your proof of work. So you do need a subcommittee of nodes on any given shard to do the proof of work. Sorry, using the right word, to do the proof of stake so that the thing will actually work with performance, because that's still a full mesh shared architecture. So you can't, I know that some nodes have, some systems have found 21 nodes as their maximum. I think we can go a little higher than that, but you still have the n squared problem. And then the overlay, which manages strictly account ownership, not transactions, runs a straight proof of stake hot stuff style protocol. If somebody wants to look up that paper, I've made a couple of minor tweaks to it, but basically that approach. And that runs, the intent is for that to run faster than the individual shard blocks. So essentially, the account negotiation of where the account should be happens faster than the blocks. The blocks then manage the actual account ownership transfers. That's the overlay of the protocol. So think of it as way to think of it as a bunch of vertical shards or vertical checkout lanes with this background scheduler that kind of points where your transactions go to which checkout counter, like something like that. And then that uses a scheduling algorithm, and that's our secret sauce. That's the core piece that solves the or tries to solve the congestion problem that you'll see in every sharded chain out there. I can tell you about that in a minute if you want it.
Awesome. Awesome, David. I know that I know it's really easy to fork a chain, and then however, I think this project has created the technology from scratch, which is
Yes,
awesome. I want you to tell us a little bit about some of the key technical milestones that the company has achieved so far, and I know that there's some alpha
yeah,
coming out as well. So, would you address
sure,
some of that?
sure. So first of all, everything's built from scratch. There's no I was not able to use any. Well, of course, we've used libraries and things like that. We're currently using the libp2p library for Gossip, using the Gossip sub module on top of libp2p. You can find that in GitHub. We're using the Go programming language and Python. Um, there's that respect. There's a block explorer which is written, of course, in JavaScript as well. We're using gRPC, which is a for Google Protobufs, a kind of a sister system to that manages the client server type relationship or client to client relationship. Um, Milestones. So the very first thing we did is we did a few phases. The very first phase we actually did was wanted to implement once our first class object model, meta class model, which is the core piece that enables the account model that enables the input to a scaling scheduling algorithm. And we implemented that actually initially as just a trial proof of concept on Hyperledger because it turned out it was relatively easy to work with that. I couldn't scale it, but I could do that one piece. We actually implemented that not with Python, but with a very manual Go approach to it. Put that together, verified, used that to then come out and start asking basically the industries, various places, hey, does this look interesting? Should we go do this? We got a very positive response. The next milestone was re-implementing that one piece in Python so that you now can execute a transaction and start supporting an object state database that is account based. So an account is an object. So when I mean by an object, I mean that the classes, the code for the classes is actually in the database itself. Not You're not compiling code into a program or into a smart contract. You're just instantiating objects from classes that exist in the database and the ability to add new classes to the database. So it's an ever increasing scalable system supporting both regular inheritance and multiple inheritance. So you can do what's called mixin classes as a set of foundation class to make this run. So we verified that piece, proved that all works. Can it be more optimized? Sure, but absolutely is running system. Went off, took the bypass to go build the consensus state machines in Go using protobufs, gRPC, the libp2p, all those types of things, and did the object state database using something that supports our sharding model with multiple trees, and it's a relatively complex system to make happen. But the end result from the user point is you send transactions in, you get your object state managed for you. Then the next core piece, two more pieces, designing out the financial model, working with Dr. White for the last year or so. More than that, I think, on what we want to be able to do there. And there's a lot of details of how that makes it possible to have a relatively stable currency. How to, when I say relatively stable, I programmatically stable, not tethered, not what you call a stable coin or whatever the other terms are. It's still its own self-managed currency. And then the last piece is the scheduling algorithm, which is coming up with a partial solution for what's known as an NP-complete scheduling problem, which is the the equivalent, whether you're talking about sharding, multi-core CPUs, or traveling, is actually known as the generalized traveling salesperson problem. And our solution to that is how we do account assignment, which makes it possible to make the scaling happen. Everything else you need is the infrastructure to be able to make that one thing happen. And the milestone is we did an initial proof of concept, standalone. Hey, let's just run this algorithm. Does it actually work? Then built a second round, that's built up for this, and then integrated into the system. And we're in the middle of putting it all together so we have a development test environment for people to run. Currently, we're running both a bunch of simulated nodes on single machine, and then we're running multiple nodes using Docker containers in the Docker overlay network, so that you can scale out on multiple machines for test environment. Our first release for this, by the way, will be that you, as a developer, you essentially run your own chain, not connect to anybody else. Start it up. You can run transactions to it, try it out, runs with its own databases, do all those types of things. And then obviously eventually we'll put up a full test chain that everybody can connect to as soon as we take it public. That's good.
Awesome. I want my own chain, David. Um, but I wanted to ask you, because I'm
Yes.
an AI person. So I want to ask you, how do you envision the role of artificial intelligence and blockchain evolving together? And does PraSaga have plans to integrate AI
Well,
into
first
this
of all,
ecosystem?
predictions are difficult, especially about the future. What I can tell you is what we can do, what we're doing. I don't know what the rest of the world's doing with it. We're doing two things. There's a Saga GPT under development, and what that'll help you do is um, both developers and users of the blockchain, of Saga Chain, take advantage of it. Because think of it as a global class-based system. Um, and every class is unique, and it's put up on the blockchain. Wouldn't it be nice if there's some way to find out what classes are available, what accounts are available, what designs are available, all those types of things? If I have um, a regular class browser type approach for a computer science person, sure, they can scroll through that and just imagine how much code there's going to be, and you're going to start seeing something that's virtually impossible to deal with. If I have a AI program that can start, providing you with answers to queries to it, that's a hell of a lot more accessible. Second part is we just in general writing transactions. So in the simple case of a wallet type thing, your transactions are written for you behind the scenes. Will work pretty much the same way. When you get into any sort of complex type behavior, because we can support essentially an unlimited amount of complexity of a message passing system, you start running into, hey, how do I write these transactions? And we don't want to end up with, you need a computer science degree to be able to send transactions. So, hey, we've got the computer science person in your AI program right here for you. So that's a second way to look for it. And just as a general learning tool, be very helpful. Obviously, there are tools for internals for developers who want to work on our code base itself. I separate the classes and transactions that run on the chain versus the chain itself. Those are two different things. There'll be some application of that there. I'm not sure how useful that is for the general public, but it might be useful. Then there's a place that we have a possibility for that's unique, which is in the internals of the system. Again, back to how you schedule where the transactions will execute to maximize the capacity of the chain. There are opportunities for using an AI algorithm as a scheduler to anticipate the best distribution of those accounts across the available shards, and also to anticipate dynamically increasing or decreasing the number of shards. That's not an area that we're currently working on, but it's definitely we're using a different approach with a more traditional a nonlinear search technique. But it's definitely a future direction for that piece, and it'll be a plugin. You'll be able to drop it in. It won't impact anything that's already out there.
I have one
Sure.
more question, and then I'm going to open it up to the community for questions here. I think I invited a number of technical people, either in the blockchain space for a long time, OGs, or people who
Mhm.
code. So I wanted to open up to questions. But my last question is, what is your long-term vision for PraSaga's technology? Where do you see the platform in the next 5 to 10 years?
Well, once it's up and running, it's kind of like you're asking me like, what am I going to do with the CPU? Um, you can make it virtually do anything. It's not limited to just dealing with tokens. Um, so we've been we're a member of the digital the DTC, the DCC community, the IAC community, the various other communities. A lot of
Yeah, sorry. Yeah, Digital Twin
yeah, thank you,
Consortium and Industrial Internet of
thank you.
Things. Yeah, I know. We have so many acronyms from our
Yeah, it's the
lives that it's
IATF,
unbelievable to
IEEE,
try to keep it
DTC,
straight.
OMG, the
Yeah,
Open
yeah.
Group. Yeah, I know. I'm sorry. I'm just like back, blanking on the words. What you see in those types of places quite often is, and one of the places we've looked very heavily at, is general supply chain applications. Um, it you have a many relationship. Just real quick, I'm going to real fast. Spent a little time with it. I was out of the top 10 automotive manufacturers. About 5 or 6 of them used to be my customers: Chrysler, Toyota, Ford, GM, etc. And what you have, we were 2 or 3 tiers back in the supply chain to all of them. So I got a real good look at the many to many relationship between the suppliers and the customers, and it's a mess. And you have all sorts of issues of how do you track what's going where and how do you know where it's going. Um, and you have a general problem also in the military space, which I've also spent a lot of time in, where you get gray market parts from sneaking into chains from all over the world, even into our ships, like into our military equipment with gray market chips that were bullshit, literally coming out of like, China or wherever else, just taking crap, putting a new cap on it, making it look like, hey, this is an Intel CPU, and of course it's not. You put it on the board, doesn't run, and all sorts of stuff like that. You have an immutable chain that's shared among these companies in this enclave concept, where they essentially have a better way to prove, provided you can show how it got on the chain. Garbage, you have to still have a garbage in, garbage out problem, but you reduce the opportunity for the interchange between hands of mixing in parts, doing all sorts of funky things. And I think that that'll turn out to be one of the places that'll be very interesting. I am sure there's lots of other places, but that's one of the ones we're looking at closely at right now.
Awesome. Does anyone have any questions that you wanted to ask? Please raise your hand. I'm opening up to questions. I'm sure the community has a lot of them, especially technical questions. So please do. All right. I think
Fire
Sheldon
away.
has a question, and go ahead, Sheldon.
Hey guys, thanks for having me up. Longtime fan, been keeping an eye on y'all's work for quite a while.
Thanks.
There's I can't speak too much, but I'll try to keep my question short. There's a series of charts and research I can show you from the past, like say 4 to 8 years, that show that enterprises are largely unhappy with blockchain solutions
Yes.
they've adopted. It's kind of the Long Island blockchain disease, right? They adopted something on the basis of making a business improvement and figured out afterwards that they would actually have to improve the business processes to be able to realize that benefit.
Oops.
Um, So I won't say too much more than that. I've had my hands pretty deep in this with large organizations, but that's why I wanted to ask this question. Hyperledger tends to dominate some of that
Yes.
sort of trustful market of people who are willing to do business deals with each other. I'm not a fan. I think that just, most of the time a SIM would be a better thing. Like any Splunk deployment could just record transactions. But um, to focus on my question, when you envision general message passing used with PraSaga, do you have like a sort of roadmap for integrations or a method you'd expect someone else to sort of keep up with the general message passing happening in PraSaga? For example, if I have a desire to integrate PraSaga for ERP or supply chain or IoT purposes,
Right.
Do you guys have a mindset or a strategy for adjacent systems I'd want to connect to?
Yes. So the first answer to that is yes. You bring up a couple points. First of all, if you try to run a chain, if you're your own company and you're only talking to yourselves, blockchain's not for you. That makes no sense whatsoever because you're proving your own immutability to your own systems. If you really, you can of course still keep a hash log, which is well understood. You don't need a generalized consensus among independent machines, right? If you're similarly, by the way, if you're a very static supply chain environment or any type of similar environment that has, say, like you mentioned, ERP as well, again, you don't need it. What this is good for is being able to add and subtract um, various entities dynamically into um, a relationship, into dynamic relationships that change over time without reinventing the wheel over and over again, without having to recode things, without having to do all those things. One of the common problems in the automotive space, for example, is becoming a tier one supplier. We were technically a tier one supplier, one of my companies, and we were never actually a tier one supplier. So they literally faked it because they couldn't fix their own system to make us a tier one supplier. And to give you a hint, we're in, if you drive a Chrysler automobile since about 2000, I don't know, 16, 15, I don't know, you got my software in there personally. Right, I sat in their parking. I sat there and made it work for them personally, and we were a tier one supplier to them, and never became a tier one supplier because their own systems were too hard for them to update us. So you get anytime you're into a many dynamic relationship, you need that capability to create and destroy those relationships. If you're in a system that already is based on objects relating to each other, you can have a relationship from an object in one account to an object in another account, or a many to many in any direction you feel like, and dynamically change those over time. That makes that makes the type of question you're asking possible. And then the second part is, why run a private chain when you can have the hash power and security of a public chain while still maintaining your own security?
Sure, I'm definitely with you on the not just plopping down R3 and leaving it up to the lawyers when something goes wrong. I definitely like doing things resiliently on the, I don't want to say the front of it, but the middle.
Yeah.
So I just have one
Sure.
relatively short follow-up question on the subject. So given the way you describe objects in like a many-to-many relationship or environment,
Right.
would you see the way that people adopt PraSaga as kind of like an overlay or sort of on top of existing systems before they could be modified or streamlined? It sounds like you're relying a little bit on the sort of like copying property that someone's willing to volunteer the data they're already
Not
mishandling
necessarily.
or handling.
Not necessarily. You got to remember that it depends on what you want to use to uh, consider quote data. Um, it's perfectly viable to just prove hashes on your own local chain, or to do an enclave of, yeah, we're going to share our data. We're only going to share the relevant data between entities that actually are trusted, and then we're going to use the rest of the chain as security only. So I don't quite think that that's the problem. The second part of the question, though, is integrating with existing systems. We're in general, our transactions are little scripts and programs themselves. you're perfectly free to design whatever it is you feel like fits with your systems. So I don't control that. We don't control that. We don't limit you in any way. And in a lot of ways, we're much more flexible than the smart contract model. Actually, we're far, far more flexible than that. So I would expect that you'll see lots of different integration solutions. Just one thing at the dig down to the API level real quickly. We are gRPC right now for sending the transactions are straight text. They're Python scripts. They look like Python. They're stylized Python. There's a little more to it than that. We will, of course, do a JSON RPC approach to it as well. Just that for the node messaging, it was a lot easier to use protobufs. So that's how the system works right now. Putting another open gateway for clients is trivial. Just it's on the list.
Understood. Well, that'll do it for me. I hope to hear more about the sort of like DevNet to mainnet kind of transition in the future, but I know that there's so many like detailed esoteric things I could ask you, so I'll just I'll wait my turn for that one.
Send into the company. I'm happy to discuss. We're always happy to get other people's opinions and ideas too. So, anyways, open.
Awesome. Thank you, Sheldon and David. Does anyone else have any other questions for David since he's here? Marcus, do you have any questions?
Please feel free. You have my undivided attention.
All right, awesome. I feel like we covered everything, so no one else has any other questions.
Sheldon
If they
still has his
don't,
hand up, but I don't know if he meant that or not.
Oh, I tried to put it down a minute ago. I was trying to just be polite, but thanks. Yeah,
Sure.
I'd love to go into a thing about the process where I sort of run my own independent Python-based logic and then join it to the mainnet when the mainnet launches. But I also don't mean to put you on the spot. I figure that's a work in progress. Launching a blockchain is a painstakingly refined process. So
Yeah. The short answer to that is I have to spend some time explaining what our architecture looks like, and that you can put regular Python code essentially into a class and callable from individual objects. It's a different model, though. You're not writing a Python program, so you have to change your mindset a bit about how you're using it. But there is some, in fact, that's a big point, is to be able to support that capability. It's currently using a straight pickle, which is a Python serialization capability, and at the moment in the current state of development is if you do the wrong thing, you'll kill it. So we have to work on better. I don't know what the right word is. Make it more resilient so that if you actually do something wrong, it won't bring down your class and your object and never be able to use it again. But
I don't know. Oops, deprecated sounds pretty cool. There's something permanent about blockchains that is part of the business's responsibility to get right the first time. I see that in public chains all the time. I appreciate your point because things need to be able to be changed. But
yeah, well, there is that.
There's
also we will have a versioning capability, which allows you to reversion a class. But you then get into mutation issues of, do you want to allow to mutate an existing object that's based on that class? And the answer to that is it depends. So remember, we're mechanism based. We'll build you all the stuff in the world out there. I don't always recommend using all of it though. So that's but
I'd love to see a framework for automatic deprecation with a like AutoGen UUID or some generic hash or something like that. It sounds like an interesting way of versioning, like, hey, oops, you broke production, this thing now needs to be fixed.
Yeah.
Then you can reference the broken object and bring back a class that's actually useful.
Right,
That's pretty cool.
Stay forward, fix the mutation, all that. Yeah, those are tough problems. Let me phrase that. Those are problems can all be solved. They're tough problems to solve where you don't take a huge hit on performance.
Understood.
Yeah.
Awesome. I think Nathan also has a question. Nathan, you wanted to ask your question?
Yeah. Hey, how you doing?
Great.
We were hanging out at this brunch when we did the venue walkthrough for the Breathe conference a long time ago.
Cool. I don't know what
Yeah,
you mean.
I'm the guy that yeah, I have no idea what happened with that. I was just in town when we did the walkthrough. So anyway, we fell out of touch. I'm the guy that organizes the blockchain stage over at DEF CON. And I know that I was talking to you and I think your boss. Do you remember this conversation?
Yeah, it was myself actually, Nathan. Yeah, Mike.
Yeah, hey.
Oh.
Cool.
Okay. Yeah, no, I saw you guys were hosting a space. I wanted to get back on here and get linked back up with you guys. And just talk a little bit about security research and education. So it doesn't have to happen here now. This probably isn't the best venue for it, but just wanted to get back in touch with you guys.
Hey, I remember I've been to DEF CON, Black Hat and DEF CON. Not in the last few years, but 20,000 plus people. Oof. That's It's wonderful stuff. There's different questions about security, right? There's the security of, is the chain immutable? There's also security of, is your code on the chain going to, be a rug pull, that type of thing. One of our positions, it's a soft position, it's qualitative, not quantitative, is that if you're running a inheritance model of code, then most of the use on the blockchain is actually using the same code. So it's kind of like the same idea as the open source. Everybody's looking at the same code. If there's a bug in there, everybody's going to see it, right? Which is it's going to happen a lot faster than if somebody threw out a new smart contract with its own code, and you now have to walk through that code and hope that there's not something you missed in it. So what you get out of it is, think of, and we will probably do this, by the way, create essentially a set of certified classes that say, hey, these things have been heavily verified. You can use them. And to use them, all you do is say, give me an instance of that class. Gives you an object, presto, you're using it. So you have a much, hopefully a smaller attack surface for that type of environment. That said, of course, this is software. As everybody find out, there is no such thing. If you the mathematical proof, the incompleteness theorem guarantees that there is some way to hack everything in the world. You just try to make it really, really hard. Sure.
Awesome. If you guys cannot hear us, please leave and then come back. I think there's some rugs here. Just want to make sure that people get to ask questions and listen. Because I'm enjoying the conversation. I know that is super technical, but it again is fun and is about really building something.
Oh, sorry. Let me interrupt. Nathan, please make sure to connect with Mike, by the way.
Thank you, Nathan. If you cannot hear anything, please leave and
is that why a bunch of people just dropped and came back? They keep coming and going. I didn't realize.
Yeah, because Twitter sometimes rug, so people can't listen. So I think it's just the better solution is just to leave and then come back. Because I have people who ping me that
Yeah, well, I'm on
hear.
an old-fashioned cable, which has 200 megabits down and 15 megabits up. So that's welcome to pre-fiber. Charter, Spectrum. Okay. If they're listening, you suck. Sorry.
I'm actually looking forward to. I'm looking forward to Starlink.
Yeah, that's cool. LEOs, low Earth orbits. Yeah. Except the only problem with them is if they ever collide, you're gonna have debris everywhere.
But they're powering a lot of the airlines too, and doing hurricane season, like what happened to Tampa right now. I think Starlink is going to be perfect for emergency situations like that.
There's another system going up by the other satellite vendors, HughesNet, Viasat, that type of stuff. Low Earth orbits, they're really cool because you're like 100 millisecond up and down. I was using HughesNet, and it's a 3/4 of a second up and down. And so be interesting to try to run nodes across the satellite system like that.
Hey, David, on that topic, what do you think about computation and, and energy and power? And, I think we're at mining just route the other
Yeah.
year, and I think the world is moving to clean energy. And I know that fusion is still a moonshot, and we're still not there yet. But what is your opinions about? Do you think that there will be a bigger convergence in because I think like I see AI growing bigger.
It takes a lot of
I
power.
think we're
Yeah.
moving. Yeah, we're moving from gen machine learning to machine reasoning now, and and single AI used to bot communication, and compute, and then at the same time, AR and VR
Yep.
are not supporting a bigger community right now, right? So, how do you see that playing a role in
Well, actually, I
blockchain
was going to do
ecosystem?
something a little more mundane. There's an interesting little piece when it comes to power consumption for the blockchain, right? Um, the problem, of course, with the Bitcoin world is no matter how many machines you put on, it doesn't run any faster, but it does consume more power. If you shard a chain, the more machines you put on, the more capacity you get. So essentially, you get a improvement in the power to capacity. Or actually, think of it that way. That ratio stays constant, which is better than having the capacity stay constant and the power increase. So that is an advantage of the sharding model over even probably like a Solana model. I think you're asking slightly different questions, of which I'm, my knowledge base in some of those is more than others. Um, the my personal opinion, there's three relative things interesting. Way back when a battery company called A123 came into existence, that was basically the DOE funded them, and that was actually over a cup of coffee. I was at a conference with the DOE and sat down and said, look, we need better batteries. And A123 came out of that. That was supposed to be a spinoff out of MIT for some nanotechnology. I don't think it quite worked out right, and they eventually went under. We need, obviously, better batteries, and we need batteries that are based on elements that aren't going to run out anytime soon. What we have right now, even though they're great and the cars are great, is probably not that sustainable. Um, and I don't know what the answer to that is, by the way. I'm hoping that somebody in a lab comes up with, hey, I figured out how to make it run with CMOS type technology. Um, there is a technology out there claiming that they have a solar panel with near order of magnitude better efficiency. So their efficiencies are now what? I believe I heard max 22%. Maybe I'm high, maybe it's 18. And somebody's saying they can get way up there. Um, Again, you get those things, and then those claims either happen or not. We need better solar panels. We need cheaper ways to manufacture them. We need those things. But I'm a big nuclear power guy. Um, I believe strong. First of all, I think we should be doing fission reaction right now. There's better ways to do it than before, especially because hey, we made all these really great control computer systems with wonderful message bus architecture and an internet that works in all these embedded systems, and we ought to be able to control a nuclear power plant a shitload better than a bunch of guys staring at a bunch of dials all day long, which is what they were doing. And we have, oh wait for it, AI that'll actually pick up problems early. Um, and then the fusion. They keep promising fusion. I don't know. I mean, when I was in college, the big EMAG test, both in engineering and physics, was around a toroid, a donut-shaped thing. And I was wondering, why are they always giving this on every test? It's because they were trying to make a toroid for a fusion reactor, and so that was the approach they've been trying to do with a containment around the using magnetic containment so that the plasma doesn't touch the walls. Um, there was recently the proof of ignition that they can do for a microsecond or something. I don't know. And there was a company that claims that they were doing some very strange looking design where it looks kind of like two bottles pointed at each other and colliding in the middle. And it was probably bullshit, because if they actually did that and they stood in the room, they were going to die because they had no containment around it at all. I was watching a YouTube video. They're going, yeah, better not turn that thing on. So I don't know. But if we can get to fusion, hey, that's home free. But that's where I don't believe that the long term solar and wind is enough by any stretch of the imagination. But I think it's a good stopgap. Hey, in the way DSL over copper was a good stopgap to get to fiber, right?
Yeah. I've met some of the fusion companies. I'll share that with
Cool.
the community. But I'm hopeful. I mean, it's still a moonshot, but I'm confident that a lot of PhDs are working on that. So, hoping that would. I know that a lot of people still don't have access to the internet, but I'm hoping that more people will have access to the
Sure.
chains, because it is Web3 and is co-ownership, and and that it is a little bit more revolutionary, outside of all the hype and the the graphs and the coins and all the prices and stuff like that. There is still technology and it's still a ledger, and that is still a change from the past. So I'm really excited about that. David, I wanted to thank
Mm-hmm.
you for being here, and for the chat. Thank you for your time, and thank you for all the PraSaga team and everyone who joined and stayed. Hopefully you enjoyed this really really nerdy chat with us, and see you again next time.
Hey, Michelle, I'd like to
Uh-huh.
bring one thing up to Sheldon, if you're still
Sure.
here. So one of the things that we're in the process of doing over at the Digital Twin Consortium, Sheldon, and why we're working with them, is to start to develop process flows within different industries, i.e., what is the general process flow of a blockchain? Is there like an overall generic, and in each, but everybody customizes it down below? We do believe so. Like, for instance, there's an example of the the supply chain class tree, just an example, but it's got like class fungible asset, class non-fungible asset, class part, class assembly.
Mm-hmm.
What we're doing is defining these process flows and then finding out which objects in there, i.e. a part, have generalized definitions globally. So we can now standardize, make it an international open standard under IETF, ISO, IEEE, and other bodies. To this is how you represent a smart, or this is how you represent an asset or an object on a blockchain as these programmable smart assets. One of the questions we always have is why. We know what a fungible asset is. It means the same thing everywhere. Why do we keep writing what a fungible asset is, i.e. a smart contract, where you clone that smart contract, basically be duplicating it and put it right back on the thing, instead of make it instantiating from a single global instance of code, so that anywhere in the world you see a part, you know exactly what that is, and it's going to be defined with every other part. You just customize what your part happens to be. We are now starting to put together two things. First, with the DTC, in order for them to do this, and it will create these design docs, and then they will go to the working groups and they'll run test beds, where the enterprises that are part of DTC will then apply or implement the code to to see if it does solve and work within their enterprise. The second thing we're doing with that is, from those docs, we're doing our own separate proposals for submission to standards bodies of those assets and such. So if you are interested, or anybody else on the phone, in participating, we would love to have, we'd love to be in contact, because we believe that this is one of the things you were asking about, Sheldon. This is how we believe that we can now, because we have this single class tree, because we can make single instances of code to represent always used objects. we have a good ability or capability to like expand this beyond. And if any of that made sense.
Awesome. I'm in contact with Sheldon, so yeah, I will basically connect you guys on Telegram or so. Awesome. I think we're going
Thanks.
to end this chat. Thank you for everyone for coming. I love technical discussion. I think they're fun, and I think they're the builders who are making this happen. So appreciate all the work that you've done, David, and thank you for making this happen. Thank everyone for coming and all your awesome questions. Alrighty, see ya next
Thank you for
time. Bye
running it.
bye.
Have a good afternoon.
Okay,
Bye,
bye
everybody.
Thank you,
bye.
everybody.
Thank you.
Bye.